Okay, so what statistical test should we do? We're sitting here, we're doing a study, we get a couple of numbers, we want to find out if these numbers are if the differences between these two numbers, the observed difference, we want to find out if that is statistically significant. Well, the most basic kind of test that I want to show you is this chi-square test. It's pronounced chi-square. And we decide to do a chi-square test whenever we are, whenever we have nominal, that is a categorical independent variable, and also a nominal or categorical dependent variable. So when we're dealing with categorical data, nominal variables, in both, this is important, the independent and the dependent variable, then we do a chi-square. I'm not going to be able to show you an in-class SPSS example, but I will kind of walk you through an example. So this is very common in content analysis, because in content analysis we work with a lot of nominal level data. So let's just say we're doing a content analysis of the New York Times. We're going to compare the New York Times with the Los Angeles Times, right? We want to find out which of these two newspapers, let me think of a topic. We want to figure out how different these two newspapers are, or similar, in terms of basic topic selection. So we do a content analysis, we get our little coding sheet, right? And the very first question in the coding sheet is what? What's the newspaper? Number 1, New York Times. Number 2, Los Angeles Times. Then the next question is, and we assume that our unit of analysis is the article, the entire article. The next question might be, what is the topic of the article? And now you've got there's a list of topics. There's foreign policy, healthcare, education, war, whatever. You have all these different, protests. You have all these different topical categories. And you're going to go through and your coders are going to select. So now at the end you're going to have a bunch of numbers, right? You're going to want to compare the New York Times and the Los Angeles Times, and you might get a bunch of numbers. It might say, I'm making this up, it might be that 19% of the New York Times articles focused on President Obama domestic policy. And the Los Angeles Times, it was only 13%. And you're sitting there going, gee, I wonder if that's different. I mean, 19% is different from 13%, but I have to do the test. I don't know, because I took a sample, right? I didn't take a census. Usually we take samples. Well, if you take a census, by the way, you don't need to do a statistical significance test. Any difference that you find is just a difference. I mean, it's a real difference, right? So you do the test. Now, what test should you do? Well, ask yourself, what kind of data am I working with? The independent variable in this case is what? The newspaper. New York Times, LA Times. That's a nominal variable. Categorical data, right? The topic. You're going to have all these different topics, just categories. That's a nominal level variable. In this case, if you have a nominal level independent, nominal level dependent variable, you do a chi-square test. And it's actually quite simple. If we were in class, I'd show you how to do it. In SPSS, we'd enter some make-believe data, and then I would show you what to do. It's simply just a matter of literally clicking on chi-square test. I mean, you do cross tabs, and then you click on chi-square, and then in a second, the computer spits out the number at you. And the number that you look at is the p-value. It's going to say p equals point something. If it says 0.005 or 0.05 or 0.04 or 0.003, anything 0.05 or less, statistically significant difference. Anything above that, we say there is no statistically significant difference. So, there's also the t-test. We have a two-sample t-test and a one-sample t-test. So we do a two-sample t-test when we have a nominal categorical independent variable and a continuous dependent variable. That means like a ratio level variable or an interval level variable, and even some ordinal level variables, right? There are some scholars that would say you can do a t-test if you have an ordinal level variable. So you have a mix, right? You have a categorical variable, you have an independent variable that's nominal, like newspaper name, right? Like in the example I just gave, New York Times, LA Times. Let's just stick with that example, right? We're still good. We're going to do a chi-square test, but no, we're not, because I'm going to pick a different kind of variable for the dependent variable. So now, instead of looking at topic choice, let's say I can think of something continuous. How many times do the newspapers quote Republicans? We're going to measure it with a ratio level. We're just going to just count up how many times, like 1, 3, 5, 8. However many times, you're just going to write that in. That's a ratio level variable. So now you're going to have an average, right? So you're not going to have a percentage anymore. You're going to have an average. It's going to say like the New York Times quoted Republicans an average of 1.1 times per article. The LA Times quoted Republicans an average of 1.7 times. So is there a difference between 1.1 and 1.7? Again, if you did a census, you would say, yeah, of course there's a difference. But we didn't do a census. We did a what? We did a sample. We took a sample. So we have to do the test. And in this case, we can't do a chi-square test because the dependent variable is continuous. It's a ratio level variable. So we do a what? We do a two-sample t-test. Okay? And the two-sample t-test just measures whether the means of two groups are statistically different from one another. This is very common in experimental design. You've got your two groups, right? You do an experiment. You've got group that watches the violent movies, and then you've got the group that's the control group that doesn't watch the violent movies. And now you want to measure their level of aggression on some kind of an aggression scale that you developed. It's like 1 to 5 or something. So this group has a 3.8 and this group has a 2.9. Are they different? Well, you can do a two-sample t-test. Okay. The one-sample t-test is just like a two-sample t-test, but the one-sample t-test compares within one group. So we don't actually have two groups. So for example, if we wanted to compare the literacy scores of women and not men on some like reading test or something like that, some literacy test, but instead of comparing two groups like women and men or young people and old people, you're going to compare just one group with some expected value. Now, this is not that common. So in our field, I mean, I don't see, when I'm reading studies, I see a lot of two-sample t-tests, not as many one-sample t-tests. ANOVA. ANOVA is also a type of t-test. You're still going to end up getting, with the chi-square test, it spits out something called a chi-square statistic that leads to the p-value. With a t-test, you're going to get something called a t-statistic. And then that gives you, if it's a big T, I can usually just look at the T and tell you whether or not it's going to be statistically significant, the difference, right? If it's a big T, usually that means it's going to be the p-value is going to be really small. The ANOVA is very simple, very similar. ANOVA stands for analysis of variance. And it also gives you a t-statistic, right? But we do an ANOVA, we don't do a t-test. We do an ANOVA when we have a combination of nominal categorical independent variable or variables and a continuous dependent variable, right? But we have, in the case of a one-way ANOVA, we have 3 different groups. So we can't do the t-test. So when you just look at this slide, it's just like a t-test, right? But it's not a t-test. We can't do a t-test because now we have 3 groups. So for example, let's say your 3 groups are University of Alabama students, University of North Alabama students, and UAH students. Let's say you want to compare the grade point average. That's a ratio level variable. So you've got your nominal level variable, right? Your independent variable with 3 levels, UAH, UNA, and University of Alabama. And then you've got your continuous dependent variable, the GPA or the IQ or whatever, the 40-yard dash time, whatever you want to measure them on, the base of their height. Okay? Now you can't do a t-test because you've got the three groups. You can do a one-way ANOVA. And a two-way ANOVA is just like a one-way ANOVA, except that we have more than one independent variable, right? It's exactly the same, but now we have two, for example, independent variables. So you might, for example, want to see the differences between college students' internet use by gender. So now let's go back to the previous example. You want to look at internet usage, but you have three universities, right? But now you don't just want to look at the students at these schools just as a broad category. You want to break it down by males and females. So now you basically have two independent variables. You have the university and you have the gender, right? And the dependent variable would be, what's the example that I gave here? Internet use, right? That's your dependent variable, right? So similar, again, in all these tests, these last four, the one sample t-test, the two sample t-test, the ANOVA, the one-way ANOVA and the two-way ANOVA, those four tests all give you a t statistic, and they're all very similar. So on a test, you might say, well, what would he do? What would the professor do on a test? What I might do on a test is I might give you a scenario, a situation. I might say, okay, here's a situation. You're doing a study on the effects of playing a video game on your levels of aggression, and you're going to measure the video game in this way, and you're going to measure the the aggression in this way. What kind of test would you do? So the first thing you need to do is figure out what kind of data am I dealing with. And then how many levels, how many independent variables do I have, right? That's what you want to do. It's pretty straightforward. It might be a little bit confusing right now, but if you watch this back, and especially if you do the reading, you might do a little Google search too for chi-square or when to do a certain kind of test. But the problem with that, be careful, because if you start searching on the internet, there are a lot of tests, guys. You're going to start getting into reading about factor analysis and regression and all the stuff that we're not studying. This is actually very basic. You just got a few tests that you have to deal with. Chi-square is the easiest to identify, frankly, because it's just nominal level data in both the independent and the dependent variable. So anyways, that's lesson 8. That's all I got. Let me know if you have questions as always, and I'll get chapter 9 posted probably in the next several days. Keep working on those final projects. That should be your focus right now, in addition to just keeping up with the lectures and the reading.